Hi guys, so in my last two videos we talked about the sine of the double angle, the cosine of the double angle and the tangent of the double angle. I already put those formulas right here and you should also have them on your formula sheet. Guys, now let us see how we can actually use those formulas. Here I have an example where what is given to me is the tangent of an angle, it's -5/12. It also tells me that the theta, the angle is in the second quadrant, which tells me where I have to draw my reference triangle, and based on that we have to find the sine of the double angle, the cosine of the double angle, and then in my other video I'm going to do the tangent of the double angle. For the tangent I'm going to show you both methods using the ratio and using this one, and then it's up to you which one you want to use at the end of the day. Okay, so to do something like this, guys, the first thing is you want to draw the reference triangle. Of course, here we are going to draw it in the second quadrant. I'm going to underline this important information. So let's go ahead and draw the reference triangle. So let me draw the reference triangle right here in the second quadrant. So it is in the second quadrant, which is going to look like this. Guys, keep in mind the reference triangle is always with respect to the horizontal axis. That is also something like that. Sometimes when I see students work, sometimes they make mistakes and they put the reference triangle with respect to the y-axis. Guys, the reference triangle is never with respect to the y-axis, always with respect to the x-axis. So this is my reference triangle and the reference angle. Of course, the reference angle theta in this case is like this whole angle, but for convenience purposes, we can call this as theta, okay? Just to make life easier for simplification purposes. And then the tangent, we know the tangent. What is tangent in terms of the sides? So SOHCAHTOA again, tangent is opposite over adjacent. So tangent, we know is tangent of theta is opposite over adjacent, right? It's also this ratio of sine over cosine, and in terms of the sides of a right triangle, it is opposite over adjacent. Now, if this is my reference angle, then obviously this is going to be my opposite, which in this case is 5. Well, here one may think that it is -5, but I cannot put a negative here, guys. The y-axis it's on the positive, it's above the x-axis, so it's y-axis is positive, so I cannot put even if there's a negative here, I cannot put a negative here. I have to still keep it as a +5, okay? And then the adjacent, this is the adjacent side, which is supposed to be 12, but it's on the left side, so it's going to be, this one is going to be -12. And guys, it does not actually matter whether we put negative here or here, but we know that when we actually express any negative fraction, we always like to put the negatives in the numerator. But if we keep a negative in the 12, that negative is, we can take it upstairs and it is still going to be -5/12. So these are the two values here. Opposite is 5 and adjacent, we like to think of that as -12, okay? So guys, keep in mind, we're not saying that the lengths are negative, because lengths cannot be negative. Lengths are always going to be positive, but this is just the how far, like this is the direction piece. This is more like thinking in terms of the direction. It's to the negative, above is positive, below is negative, okay? So, and for calculation purposes, it just gets our job done. So this is my adjacent, this is opposite, and the hypotenuse is something that we do not know, and we can just use the Pythagorean theorem to figure out the hypotenuse. Probably you guys already know that this is that special triangle 5, 12, and then 13, but if you are not sure about that, then you have to do like 12 square plus 5 square, and which is going to be 144 plus 25, which is 169. You take the square root, you got a 13. So the hypotenuse or the radius, whatever you like to think, is 13. Guys, we have the all the three sides, and then based on that, let us go back and start writing the formula for sine of 2 theta. Sine of 2 theta we know is twice sine theta cosine theta, right? Just using the double identity property. And based on this, we have 2 times sine of theta. Sine of theta will be, we know sine is opposite over the hypotenuse, so it is 5/13, right? I'm just using the reference triangle. There's nothing really crazy going on here. Given this, we just draw the reference triangle in the second quadrant, because it says in the second quadrant. We've labeled the sides kind of based on the given information, and then we find the missing piece. In this case, it was the hypotenuse, which is we found out to be 13, and we write this 5/13 here. And cosine of theta we know is the adjacent over hypotenuse, which is going to be -12/13. We've got to simplify this, guys. Simplify carefully. There's an invisible one here, so 2 times 5 is 10. 10 times -12 is -120. 1 times 13 times 13 is basically doing 13 times 13, which is 169. Okay. And guys, well, let us see what we have here. A sine, yeah, so that is what we get for sine of 2 theta. Okay. Similarly, let us do the cosine of 2 theta. For cosine of 2 theta, it's up to you whether you want to use 1, 2, or 3. So, well, let us use, in this case, let us use number 1. Okay, I mean, guys, it does not matter. You can use any one of those and you should still get the same answer. So let us use number 1. So cosine squared theta minus sine squared theta. Cosine squared theta, I already have the value for cosine theta. Cosine theta is adjacent over hypotenuse, so negative 12 over 13 whole square. Guys, I'm just still looking at this reference triangle. Minus sine squared theta. What is sine theta? Sine is opposite over hypotenuse, 5 over 13, right? 5 over 13 whole square. It's all now about simplifying. Simplify step by step. Negative 12 square is 144. 13 square is 169. Minus 5 square is 25. 13 square is 169. I have the same denominator, so I can combine the numerators. 144 minus 25. And 144 minus 25 is going to give me 119 over 169. So sine 2 theta is negative 120 over this. It's negative. Cosine is 119 over 169 positive. Okay. This is sine and cosine 2 theta, guys. It's not too difficult once you understand how to draw the reference triangle and how to label the sides. But keep in mind, we are not saying the lengths are these, but it only helps us to simplify things. It's mostly like the direction that this is actually giving us the negatives and positives. Okay. In my next video, I'm going to do for same particular example, we're going to do the tangent. Well, for tangent, I'm going to show you both ways, and then it's up to you which one you want to use. And I mean, using whether we use the formula or we use this basic simple formula, we are supposed to get the same answer. Okay. And guys, in general, it's always good to try using few different ways of doing something, so that we can also verify whether we are getting the same answers, so that kind of justifies that both ways or both methods or both formulas are right, are correct. Okay. So guys, keep